So to begin with, we're going to do a proof, and this does start quite easy, and it is differentiation. And I've written right at the start, discuss the difference between a relation and a function. Okay, so we should remember a relation, okay, is any relationship between two variables, x and y, s and t, whatever it is. It's any relationship, okay? And then a function is a subset of relations, okay? A function is a very specific type of relation. And the simplest way to describe the difference is if we think of like the vertical line test, okay? So here I have a quadratic. This is a type of function because it passes the vertical line test in that each x value has one unique y value. It is a function, but it's also a relation. Why? Because it's a relationship between x and y, okay? So it's like saying, you know, if we think of rectangles, okay? All squares are a type of rectangle, all right? In that they have four sides, okay? Four straight sides. So all squares are a type of rectangle, all functions are a type of relation. All right, but where it gets different is when we have circles. The circle is a classic example of a relation that is not a function. Why? Because it doesn't pass the vertical line test. So in this unit, where we're going a little bit further from calculus is that we're differentiating different variables, but we're going to be differentiating relations as well as functions. Okay, so we've sort of done a lot of functions in methods. I think here more specifically we're looking at relations. And so what we're going to start with then is what we call implicit differentiation. So if we have a function, this is the chain rule, right? If we have some function that is another function to the power of n, then the derivative of it is going to be n take 1 times dy on dx. Okay? Now that formula there, that's just the chain rule, and we're going to be using that today to differentiate y. Okay, so we've got all these examples here. Let's get straight into it. Okay? It says differentiate the following. So what we're doing is we're finding the derivative of 3y. d on dx of 3y. We're differentiating with regards to x. So the derivative of 3y is going to be 3. Alright? The derivative of 3y is going to be 3. And then we have dy on dx. Okay. We're good. You're probably wondering where does that come from. Let's do a couple. It's going to make a bit of sense. We have d on dx of y to the power of 5. All right. It's going to be 5y to the 4th. Okay, that's just our power rule for differentiation. dy on dx. All right. Anytime you differentiate y, you have to add at the end of it dy on dx. Okay, that's what this is saying. If we have y to the end, we differentiate it, we have to have dy on dx. Okay, so it starts to get a little bit more complex then. Now we have this relationship here. We have d on dx of 4x y to the power of 3. So we're multiplying. Now, because we're, pardon? Oh, did we? Oh, sorry. Yep, let's do that is 3 on top of the square root of y. Okay, so before we can differentiate this, we need to put it in a form such that it's expressed at the top of the fraction and as a power. So we're going to have, what are we doing? We're finding the derivative of 3 times y to the power of minus half. Okay, now it's in a form ready for us to differentiate. The 3 is going to hang out. It becomes minus half y to the minus 3 on 2. Okay, and then we smash that dy on the x on the end here. Alright, and again, like with differential calculus, it often says without simplifying, if we wanted to express this in the simplest forms, what's it going to be? It's going to be minus 3 on top of 2y root y dy on dx. Okay, that's what that can be rearranged. Okay, on to d. We have 4 d on dx of 4x y to the power of 3. Right, so here we're multiplying two things. So just like with when we're differentiating a function, we have to consider what rule is going to be involved here. This is going to be the product rule, right? We have 4x multiplied by 3. We have two functions. So we're going to go u is 4x, which means u dash is 4. V is y to the power of 3, which means v dash is 3y squared dy on dx. Okay? Anytime we differentiate y, we have to put dy on dx. And then it's just product rule, just smash it together. The answer is going to be u dash v plus u v dash. Alright, on to E. What's this the equation of?
Circle.
It's a circle, alright? Has a center 0, 0, has a radius square root of 5. Alright, so we're going to differentiate the equation of this circle. So what we're doing is we're differentiating this whole thing. That means we're differentiating both sides of the equation. So we're going to have 2x plus 2y dy on dx equals 0. Okay, in question 2, we have another circle. Alright. Consider the relation x take 2 squared plus y squared equals 5. Determine the slope when x is 1. Okay? For a relation, the slope is still dy on dx. So it's going to say find dy on dx when x is 1. Alright, so firstly, we have to differentiate, right? So we're finding the derivative of this. Now here we have a function to the power of n, so we have to apply the chain rule. Alright, it's going to be n f of x to the n take 1 multiplied by f dash of x. Okay, n f of x to n take 1 times the derivative of the inside. Okay, so that's the first part. Then we have plus 2y dy on dx equals 0. Okay, so let's just simplify it a little bit. We've got 2 times x take 2 plus 2y dy on dx equals 0. Now, we want to know the slope when x is 1, which means we're trying to solve the dy on dx. So it's like an equation, right? And this is the variable we want by itself. So the first thing we'll do, we'll subtract that from both sides. So we'll be left with 2y dy on dx equals minus 2 times x take 2. We will divide both sides by 2y. And we'll have dy on dx is equal to, well, it's going to be x minus x take 2 on top of y. Okay, so what we've done there is we've isolated the slope, okay? So the slope of this circle for any value of x and y is given by this equation, but we need both. We need x and we need y. Now we've got an x value. We're told determine the slope when x is 1. When x is 1. So now we need to find out, well, what's the y value that we're going to substitute into this slope equation? So when x is 1, what's the y value? We're just going to use the original equation. Okay, substitute in, we've got 1 take 2 squared plus y squared equals 5. So what's this going to be? 1 plus y squared is 5, we'll have y squared is 4, and so we'll have y is plus or minus 2. Has to be plus or minus 2 because it's the equation of a circle. Alright, and so what that means is when x is 1, we've got 2 y values. Alright, so let's assess the slope for both. So let's go when y is 2, we're going to have dy on dx is going to be minus 1 take 2, so that's going to be minus minus 1. We'll have positive 1 at the top, on top of 2. And when y is minus 2, we will have, the x stays the same at the top, what's that? Positive 1 on top of negative 2. Okie dokie. So this is pretty fun, alright? It's a good revision of differentiation. Yeah, hopefully we sort of remember them a bit, probably be hardest for me. Alright, so let's have a crack at 8A, and if we've got time we can have a look at some of 8B, see how we go.